Ladies and gentlemen, good evening. Tonight we're going to look at how can we filter out elements from a list and how can we peek to see how it actually works, how the streams actually work. Because a lot of people actually they don't know what if I create some filter. Is it going through all of the elements? If I have a findFirst. If let's say I'm using the findFirst, and the answer is no, it does not do that. But you can actually find the answer yourself by using the peek method on the stream. So let us just get started. I have reused this project from my list to map demo. So and in that demo, I had a list of spaceships right here, and I initialized the list of spaceships on startup. As soon as I create a new instance of the class, then these 6 ships are being added right here. Mike, Susan, Rikke, Harriet, Janet, Mette, those are the captains. The fuel is 25%. The model is round, etc., etc., etc. The spaceship was built up like this. I'm using the data class from Lombok. I'm using the builder from Lombok. That means that I'm creating a new instance with the builder pattern. Unless I delete all of it by pressing the wrong button. Here you can actually see I'm using the builder pattern. I create a builder, and that is Lombok that generates all its code. Then I can set the captain, I can set the fuel, I can set the model, and then in the end I call build, and then an instance of the spaceship is created. Let us try to filter out some of these ships right here. Let us say that I wanted to get all the spaceships that needs refueling. So that means that somehow, for some magical, in some magic way, I actually want a list of spaceships that needs refueling. Needs refueling like this. I don't know if it's spelled correct. Refueling, 1 or 2 L's, doesn't matter. Refueling, is it 2 L's? Yeah, let us just keep 2 L's. So what we can do then is that we can actually check the ships list like this, and then we can convert it to a stream as the first thing. If you have a lot of actions on it, and if you have a lot of elements in the list, you can use the parallelStream to parallelize parallel to run the work parallel. That means on multiple cores. There's an overhead by using the parallelStream. Which means that you should not use it if the workload is not that high, because then it will actually take longer than if you are using the normal stream. So, but you can try out both and then see which one is fastest. If you're in doubt, create a good unit test where you can test it out in. So, okay, the question right here was findFirst. Let us say that I just want the first fuel. If I just want the first fuel that should be fueled, I actually don't care about the one that has the least amount of fuel. I just want the first spaceship that needs refueling. With this operation right here, will I go through all elements to evaluate the condition that are right in here? And the question is no, but the person that actually gave me the question, he could actually have found the answer himself. So let me just I'll write a lambda right here. So findFirst, we have we have one spaceship at a time that's being evaluated, and then we need to return true or false. So that means that if the spaceship right here, then if the spaceship dot fuel gets fuel, if that is less than 50, then we return true. Let me just see here. It's an optional that we are getting back right here. So this is an optional. So here we have an optional spaceship. It could both be if there are no spaceship that actually. Why can't it do that? What is the matter right here? Ah, yeah. Okay, I know. We need to filter them out. Yes. Sorry. Sorry. First of all, we need to filter. So dot filter. Yes, I don't know what I was thinking. So here we have the predicate, and here we have the spaceship. So we are filtering out the spaceship that does not match these. That is the filter operation. But we actually just want the first spaceship. We just want the next spaceship that needs refueling. So we just want a spaceship right here. Next spaceship to refuel. To refuel, like this. So we are the mechanic, or we are the gas station owner at some space gas station, and then we see there's a huge amount of spaceships coming towards us, and we just want one of them, so we can start refueling that. We don't care. There's nothing about Q or something in this space gas station right here. So first of all, we filter. We want all the spaceships that have less than 50%, because we need to refuel those. Those with above more than 50%, we should not refuel. We should not refuel those. So that means, but we just want the first one, find first. Then we get the optional right here. And if optional spaceship dot is empty, then we can throw an exception. Throw new illegal state exception. No more ships needs refueling, like this. Or else we just return the optional spaceship dot gets. That's the way we get the content of the optional. It's also pretty cool now we also use the optional. That's not very often actually that I myself am using an optional, but it is awesome. Instead of throwing an exception here, we could also choose, of course, just to return the optional spaceship instead. Let me just fudge the fuel percentage just a little bit. So now we have, let's say that we have the last spaceship right there, and then we have a spaceship in the middle. Then the question is, okay, the question now is, we have two spaceships that should be refueled, right? We have this one, and we also have the one in the bottom. And the question is, will the Java program actually run through each of these spaceships? Will it test on the fuel percentage on each of these spaceships when we are using the findFirst method right here? And the answer is no, but we can actually test. We can actually test this. So we can actually use a peak. If we use a peak like this spaceship, then we can actually see what's going on inside the stream brain, so to say. So that means that then I can let us use a log info spaceship to evaluate colon, and then plus the spaceship like this. And I need to add the logger. I'm using lumbox, so SL4J like this. So here I can peek. This method is awesome for debugging. Remove it when you know what's going on. Then remove the peak, because of course it takes a little bit of performance. So right now we are logging each spaceship that is being evaluated, and if I'm right, then we will see this ship. We'll see that ship, and then we'll stop at this ship right here, the third ship. That means that the evaluation is not going to be called on all the spaceships, because we have the findFirst. And then this is also what is so awesome. If we have sorting mechanisms and filter mechanisms, then always add the filter mechanisms first, and then add the sort mechanisms afterwards. And then you can actually see what's happening. So, but let us check it out. In order to check this out, I'll create a cool unit test. So I'll make this public next ship to refuel right there. I already have a unit test, and I think I changed the. I just want to jump to the test. I forgot the hotkey for that actually right now. Maybe it's because I'm not testing enough. I don't know. But let us create a new test right. Oh, I'll actually. Let us press Alt Enter, then create test. Then we can say we want next spaceship. I'll just add that right there. Next, it already exists, that's fine. Next spaceship to refuel, and I like my methods public right here. I actually think that it's needed. I don't know why it's, Intelli always makes them default scope. Next spaceship to refuel, new spaceship service like this, give me a spaceship, next ship to refuel. A good test always have some assertions, so let us steal the assertions that we already have right here. Of course, the assertions in the beginning, the most important assertion is that it's not null, but we also know it's not null, or else we would had an exception thrown. So I will add these assertions right here. They are wrong to begin with, so I'll actually comment them out, and then we will fill in the right value afterwards. So I'll just log I'll just system out, because we're down in the test module, in the test code. So not the test module, the test code. So then I'll say spaceship returned like this, and plus the spaceship. The cool thing about Lombok, when you are using the data, when you're annotating with data, you get a really good toString method also just thrown at you. So that is free. Let us run the tests. Let us see what happens. Did I make any errors? Spaceship returned, Regge, fuel 15%, model round. But what is more interesting is what is happening just before. We have the peak. We have the peak function method. We have the peak method right here. So that means that we're going to Mike, Susan, and Regge. And then when we found Regge, then we stopped there. And then we returned the optional, and the optional returned contained the Regge spaceship, because it was because it fulfilled the condition that we set. This is awesome. Let us just change it just for fun. Then now I'll change this to 55, and then we will change Janet to 29 instead. I'll press run again, and let's see what happens. This is so awesome. Look, now we are evaluating 2, 3, 4, 5, and we get a spaceship right here. Fuel percent 29 and round. This is awesome. There's also one method which is called findAny. What is the difference? Because the result is the same. Let us just check. Or it's very often the same. It's not guaranteed to be the same, but when you're using the stream, then it very often is the same. Or I've never seen it not be the same actually. But when you use findAny, then it's not guaranteed that it is in the right order, because this is meant for the parallel stream. And that means that if you're running something in parallel stream like this, then you can get a performance tweak, a performance benefit from using findAny instead of findFirst, especially if you don't care if it's the first one in the list. So findAny and findFirst are not the same. findFirst guarantees that it's the first in the list. findAny will just give you any one, and you can split the work out to multiple cores. So now I'm running the parallel right here. A lot of times, be careful. Now we got meta actually. So this actually proved the point. This proved the point, because now suddenly, So now suddenly we ship to evaluate right here. Let us just redo that. That's very interesting. Let us just run again. Let us see here when we run parallel stream. There's an overhead by using the parallel stream. We went through Susan first, then we went through Regge, then we went to Mette, then we went to Mike. And because when we're running it in parallel, then we're using multiple cores. This is pretty awesome. So we actually got another result now that we used findAny, and when we changed the stream to a parallel stream. There's some overhead, so remember to check if the performance benefit is, if it's there, or if it actually slows down the program by using parallel stream, because it could happen. So thank you very much for watching. Have a great evening, and as usual, just give me some questions in the comments. I really enjoy reading all your comments. They are, they're very awesome. Let me just put myself in this corner instead. Here we can actually see it again. Susan, Regge, Mette, and Mike. Maybe you didn't see it just before because my face was covering it up. So let us just run again with stream. And we can also use, here we have it, Mike, Susan, Regge, Janet, Harriet, Janet. And then now Janet is first, because it is not a parallel stream, it's just a normal stream. And we can also use the findFirst as we just did before. Then we'll get the same result again. So I think I will commit this code with the I will commit this code with the parallelStream. It's much more fun. I think it's a better use case, and it's not something people actually think about in the normal daily work life. Thank you very much for watching. Have a great evening. Hope to see you again soon. Bye bye.